It turns out that there are also several similarities between language acquisition in humans and song acquisition in songbirds, not just the similarities between the systems themselves, but both how basically the babies, either baby birds or baby humans, learn either bird song or human language, right? So it turns out that both human language acquisition and birdsong acquisition have early stages prior to the appearance of the adult form. So in human language, we have babbling that our babies will do, both babies who are speaking and babies who are deaf and are learning to sign. They'll have babbling. And in birdsong, we have bird babies have this thing called subsong, which is like birdsong babbling, right? And the babies of both birds and humans need to be able to hear their own productions, hear what they're producing in order to fine tune the birdsong or the language, if again, depending on whether you're a bird or a human. And they also have sensitive periods. So humans, we think this may range anywhere up to 7 or maybe 10, sort of depending on the situation and what aspect of language you're focusing on. For birds, it's often between 7 and 60 days old, right? But after that time, your ability to pick up the full adult form of either the birdsong or human language deteriorates, right? And it turns out that both birdsong and human language can reconstitute itself from impoverished input. So in human languages, a impoverished input would be something like a pidgin, where different languages are coming together and you have sort of bits and pieces, but not really a fully formed language to learn. And human children are able to turn that into a much more structured, systematic thing like a Creole. They create that system, a system, from impoverished input. And birdsong does the same thing in zebra finches. It's been shown that from a song produced by isolates, that is birds who did not have a full system, and so therefore you have sort of a pigeon-like thing going on with the birds as well, as sort of pigeon-like birdsong, right? Pigeon, P-I-D-G-I-N here, not pigeon the bird, but this sort of piecemeal kind of song. You start with that as your input, and over several generations you can recreate a fully formed song system of a zebrafinch. So it's that same thing of reconstituting itself from impoverished input that we see in humans. Turns out when you look in the brains, guess what? The language processing, the song processing for birds is lateralized in the left hemisphere of the brain at the end, when all is said and done, at the end of the acquisition period. And in fact, they rely, both birdsong and human language acquisition, on similar genes for vocalizing, right, when you actually look at their genome. And in fact, both humans and birds are predisposed to certain types of vocalization patterns. In particular, short and high-pitched sounds are more likely to appear in the middle of a birdsong or in the middle of a human utterance.